Hi, welcome to this lesson on Euclidean geometry, mixed exercises with polygons. Let's have a look at question 1. We're given that ABCD is a parallelogram, so that's really important because there are properties of parallelograms that we can utilize. And we're given this ratio here, CB over YB is 3 over 2. Our goal is to find the value of DS to SZ. So immediately I draw my attention to where those two side lengths are. There's DS and there's SZ there. Now, because this is a parallelogram, I know that diagonals on a parallelogram bisect each other. So that means that the length of DS must be the same length as SB, and the length of CS must be the same length as SA. Okay? So that's going to be useful for us when we're trying to work out the ratio of DS to SZ. So now I go to my given information, because that's always super important. You always want to make sure you utilize all your given information. So I can rewrite this as CB equals 3 over 2 times YB. Okay, so what I'm going to do is I'm going to let YB equal to X. Okay, so therefore we have, if I let this length here, YB equals to X, then the length of CB, which is this total length here, is 3 over 2 amounts of X. So therefore I can work out this last bit amount here by saying 3 over 2X minus X, and that'll leave me with a half X. Okay, so immediately my attention is drawn to these parallel lines here. So I can see that there's a triangle here, namely the triangle CSB, and a line YZ that is parallel to one of the side lengths, CS. So I can use the proportionality theorem here. So how would I use the proportionality theorem here? Well, I would first see, do I have any given information about the proportion or the side lengths over here? And I do. I have YB, which I denoted by X, and then CY we worked out as a half X. So by the proportionality theorem, this must be in the same proportion. So this must be in the proportion Y is to a half Y. Okay, because if we divide those two, for example, BY over CY, that's going to be X over a half X, and that's going to give you 2. Right? When you divide that, and then you divide by a fraction of half, you get 2. And the same thing must be true here. If I do ZB over SZ, that must also be Y over a half Y, and the Y's will cancel, and I'm left with 1 divided by a half, which is 2. So they're in the same proportion by the proportionality theorem. Okay, so now I can write that information there. So I can call this Y, and I can call this half Y. But notice we want DS over SZ. And DS is equal to SB. And the reason for that is ABCD is a parallelogram. Okay, so remember in geometry, you always need to give reasoning for our statements. Okay, so since that is true, I can break up DS into SB. So SB is made up of SZ plus ZB. Okay, so that's equal to a half Y plus Y, which is 3 over 2Y. So therefore, DS divided by SZ is the ratio here, 3 over 2Y, all divided by SZ, which is given by half Y. So now the Y's will cancel each other out. Y cannot be 0 here, right? Otherwise you would have a 0 length, which doesn't make sense here. So I have 3 over 2 in the numerator. When I divide by a fraction, I multiply by the reciprocal. So now I have 3 over 2 times 2 over 1. Those 2's will go into each other. And I'm left with 3 over 1, which is just 3. So the length of the ratio DS to SZ is given by 3 units. Okay, so that just means that the proportion from DS to SZ is 3:1. So DS is 3 times as large as SZ. Okay, that's how we would interpret that. All right, so that's how we would do this type of question. I'll see you in the next one.